Hi, welcome to Virtual CB1A. This is Miss Rena, and for today's video discussion, we're going to perform valuations and construction of truth tables. So we will start with the parsing tree. So what do we mean by the parsing tree? It is a diagram that yields a formation sequence of propositional forms. So the formation is found by listing each distinct term of the tree starting at the bottom row and moving upwards. Why is this important? So parsing trees are beneficial in constructing truth tables. It will give you an idea on which propositions and which compound propositions should you include in your truth table. So let's start. Say for example, you are asked to construct a parsing tree for P implies Q and R by conditional negation of P. So all we have to do is to break down this compound proposition. So let's write here P implies Q and R by conditional negation of P. So this can be written as P implies Q. And this can be broken down into P and of course Q. While for this other part, we have N. We have here R if and only if negation of P. And R if and only if negation of P can be broken down into the propositions R and of course negation of P. And negation of P is from the proposition P. Now let's list down all the components of this compound proposition. So we will start with the bottom row. We have P. Next, we have negation of P. After that, we have R. Next, we have Q. And we have, again, P. But since P is already included here in this branch, there is no need to write this again. So this is similar with the idea of subsets. If you have the same element, you don't have to write it over and over again. So it will just appear once in your truth table or in your formation sequence. Another component is R by conditional negation of P, and then P implies Q. And only then will we end up with P implies Q and R if and only if negation of P. Now let's list down all the components. So we will start with the unary ones. So we have P followed by Q followed by R. After that, you will have the negation of P. We don't need to find the negation of Q and negation of R because it doesn't appear in our parsing tree. Next component, we have P implies Q. After that, we have R by conditional negation of P. And only then will we have or will end up with P implies Q and R by conditional negation of P. And then from this formation sequence, we will be able to find the truth table for this compound proposition. So how many components do we have? We have 1, 2, 3, 4, 5, 6, 7. Or when constructing the truth table, we have to allot 7 columns. So let's write here the table. So as I've said earlier, the number of components in your formation sequence will define the number of columns that you need for your truth table. So we have here 1, 4. I think I have to copy the components from the other page. Just wait a moment. So I will copy this part and then paste it on this page. So we can have a guide. And then I will just delete this later. So for the first column, we have P. Next, for the second column, we have Q. For the third column, we're going to write here R. After that, we're going to write the negation of P. This is the negation of P. After that, we have P implies Q. After that, we have R biconditional negation of P, or R if and only if negation of P. R if and only if negation of P. And finally, for the last column, we have the original compound proposition P implies Q and R biconditional negation of P. Now, we are going to construct the truth table for this. How do we know, or how do we get the number of values to be written on the columns? Just wait a moment. Let me delete this. Okay. So to get the number of values to be inputted on each row, or to get the number of rows, all you have to do is to use 2 raised to n. So this is the formula for finding the number of values to be written under each component. N is the number of propositions given in your compound proposition. So here we have 3 original propositions, P, Q, and R. Therefore, this is 2 raised to 3. So 2 raised to 3 is equal to 8. So for here, we have 1, 2. If we only have one proposition, say for example P, and then you have to get negation of P, all you have to do is to write here true and then false. You will end up with 2 raised to 1 or 2. You only need 2 values. We have here false and true. Now, let's expand this to 2 propositions, P and Q. You will end up with 2 raised to 2 or 4. Say, for example, you have P and Q. Therefore, this is true, true, false, false. And then this can be true, false, true, false. So this is the pattern that we're going to follow. Always divide the number of rows that you will get from 2 raised to n. Half of it will be true and the other half will be false. Since we have here 8 rows, then divide it by 2, you will end up with 4 true and 4 false rows. True, true, true. False, 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 false. Bitin yung table. Ayan. Next, for Q, see the grouping here. So, we are going to divide 4 again by 2. And then 2 of them will be true and the other 2 will be false. For false, 2 of them will be true and the other 2 will be false. True, true, false, false. True, true, false, false. And finally, for R, we are going to alternate the values. True, false, true, false, true, false, true, false. After that, negation of P naman tayo. So for the negation of P, you have to disregard Q and R and just look at the values under P. So everything that is under P will be negated. So if it is true, the negation of P will be false. So since we have here true, apat na true sunod-sunod, then we are going to have apat na false sunod-sunod din. And then dito naman, apat na false, we are going to negate the value, you will end up with apat na true. Ayan. Next, doon na tayo sa P implies Q. Naglagay ako dito ng sheet as your guide. Parahin ko muna to para hindi tayo malito. This is the summary of all the operations that we discussed the last time. So we have here the negation of P. Ang valuation niya, if true, then the negation of P will be false. Valuation of negation of P, if false, it will be true. Now, dito tayo sa implication. So, this is V. Kita ba? Palalakihin ko siya. So, para mas malinaw, palakihin natin yung table. Ayan. So, for here, we are after this one. So, the valuation of P implies Q. It is false if the valuation of P is true and the valuation of Q is false. So, it is only false kapag ka true yung antecedent, yung hypothesis, and then yung consequent ay false, yung conclusion. So, tingnan natin dito. True si P, tapos true rin si Q. Therefore, this is true. Next, true si P, true rin si Q. So, this is again true. Next, true si P, false si Q, yung conclusion. So, dito siya, magiging false. So, TF ulit, this is false. And then we have FT, FT, FF, FF. Lahat sila true na. Okay? Now, let's move forward with the biconditional. For the biconditional, we will look at R and negation of P. So, this is R, this is negation of P. When are we going to have the value true and when are we going to end up with false? So, ang titingnan naman natin, itong last, we have valuation of P if and only if Q is equal to true if the valuation of P is equal to the valuation of Q. F otherwise. So, madali lang to. Basta parehas sila ng value. Pagka parehas true, true. Pag parehas false, false. Pag magkaiba ng value, isang true, isang false, false na yon. So, true, false, this is false kasi hindi sila parehas ng value. Next, false, false. True na siya kasi parehas sila ng value. True, false. Again, this is false kasi magkaiba sila. False, false. This is true. Next, true, true, true ulit. False, true. We have false. True, true, true. And finally, false, true. This is false. Let's move to the last column. So, dito sa last column, ang titingnan na lang natin, itong dalawang huling columns na sinundan niya. We have P implies Q at saka R by conditional negation of P. So, ang ating operation ay end. Ang titingnan na natin ay yung valuation ng end. Ayan. So, for end, it is true if the valuation of P or the value of P is true and the value of Q is also true. F otherwise. So, kapag pareha silang true, saka lang siya true. Pag may isang naligaw na false, false na yung buong compound proposition. So, tingnan natin itong dalawa. True, false. This is false. True, true. This is true. False, false. This is false. False, true. This is again false. True, true. True. True, false. False. True, true. True. True, false. False. So this is the truth table for the proposition P implies Q and R if and only if negation of P. So I hope that was clear. If you have any questions, please send me an email. Thank you and see you next time. Bye!